So there are two special kinds of logarithms that we like to consider. One is called a common logarithm. Common logarithms goes like this. It is a logarithm that uses a base 10. So we consider it to be y equals logarithm with a base 10 of x. But when we come across common logarithm, practice is that we leave off the base. The base is silent. So if we don't see a base written, if we don't see the base written if the logarithm, we assume that it's 10, and so we write simply y equals log of x. Now this is the kind of function that would certainly pass through the point 1, 0, because we know that anytime you take the common logarithm of 1, we get 0 because, well, 10 to the 0 is equal to 1. This is also going to be the kind of graph that passes through the point 10, 1. And that's because when we write logarithm 10, we are implying that the base 10 is written right here. So it's base 10 of 10. And just like our property before, that's equal to 1. This would also be the kind of graph that would pass through the point where x is equal to 1/10, y is going to equal -1. So right over here is the point 1/10 -1. Here's some of our other points. Of course, 1, 0, which is a standard practice. Of course, here's the point 10, 1. Quick question. Where would we get y equals 2? Yeah, well, if you think about it, it kind of makes sense. It would have to be 100. Because if we said evaluate the logarithm of 100, we're saying, all right, to what power must I raise the base 10 to get 100? And we know that 10 squared does that, so y is equal to 2. That would be another point on this graph. Now, the other kind of function that we have is called a natural logarithm. As referred to in the previous section, section 4.2, the base e, recall, is Euler's number. And it's considered the natural base, the number 2.71828182828, and so on. It actually never repeats, never terminates, so it's an irrational number. And whenever we have a logarithm with that kind of base, we don't write y equals the logarithm base e of x. Instead, we abbreviate and we use the term ln instead. We write y equals ln, standing for logarithm natural, or natural logarithm of x, and we don't write a base next to it at all. When that's the case, what happens in this case, we have the kind of function that, again, passes through the point 1, 0, because just like all good logarithms, the natural logarithm of 1 is equal to 0 because e to the 0 is equal to 1. Any base other than 0 raised to the 0 is 1. This is the kind of function that when x is equal to e, y is equal to 1. So in other words, this is the kind of graph that passes to the point natural log of e is equal to 1, and that's because e to the first is equal to itself. So this graph passes to the point e1 right over here. And of course, we could just, in a very similar fashion to what happened with our last graph, say, well, if we had a fraction, 1 over e, slightly less than a third, we would get -1. Because, well, e to the negative first is 1 over e. And so this is the kind of graph that passes through the point right here. Across the x-axis, this would be the point 1 over e, -1. So this gives us a basic idea of what these basic natural log and common log functions are like. Again, if you see no base written to the word log, we assume that it's a 10, unless we write otherwise. And if we see no base and we use the letters ln, we are indicating that it is a logarithm with a base e. The notation is very important to us, so I want to make sure that you guys have that one down. More to come in the next video.